everyone, I am going to explain question number 7 and 8 from exercise 7.5 from class 12. So we can see the question, y is equal to sine inverse x, then we have to prove this result, and to prove this result we will see what thing we require. So here we need the second order derivative and as well as the first order derivative. So we will start from the given equation, y is equal to sine inverse x, differentiate with respect to x. So when you will differentiate here, dy over dx will come in left hand side, and differentiation of sine inverse x direct formula is that 1 upon root 1 minus x square. Since we have to differentiate it further to obtain the second order derivative, so this thing you just write down as x to the power n formula. So since 1 upon root 1 minus x square is there, so since it's in upon, so power becomes negative. So negative half you can write. So it will behave as x to the power n. Now differentiate it. When you will differentiate again with respect to x, here you will get second order derivative, and here x to the power n is n x n minus 1, and then use the chain rule in the bracket. According to chain rule, when you will differentiate, one's differentiation it's a constant, so 0, and x square differentiation is 2x. Now this one, so minus half and minus 1. So minus half minus 1 will get add and becomes minus 3 upon 2. Since minus 3 upon 2, so you will shift it down, so it becomes plus 3 upon 2. This 2 and this 2 will cancel, and minus becomes plus. So you will obtain this. Now here you will have 3 upon 2 power, so that you can write as 1 plus half. So means you can write like this. Now this is your second order derivative. Now we have to prove this result. In this result, second order derivative value is a substitute from here, and first order derivative also in left hand side, first left hand side, substitute their values and just open. Here you can see this bracket and this bracket can cancel each other. So we are remained with these two terms and they will cancel each other. So we will get right hand side. So like this, question number 7 is completed. Now we move to the question number 8. Question number 8 we have y is equal to sine inverse x square. So in this also second order derivative, first order derivative. So first write your function y, then differentiate it with respect to x. So when you will differentiate, first it will behave as x to the power n, it is n x n minus 1. Then according to chain rule, you have to differentiate sine inverse x, that will give you 1 upon root 1 minus x square. So you will obtain this. Now to further differentiation, to get the second order derivative, you have to differentiate it with respect to x again, and here you have the fraction. So when you will differentiate this fraction, you have to use the numerator upon denominator formula. And so what is the formula of numerator upon denominator? That is denominator square, then denominator as it is, the differentiation of numerator, then numerator as it is, and denominator square. So you have to, since it's a fraction, so you have to use the formula of fraction. So now we'll see how we'll differentiate it. First this term as it is, then differentiation of this, that time this 2 will behave as the coefficient, and sine inverse x differentiation is 1 upon root 1 minus x square. Now here this minus symbol as it is, and this term also as it is. When we differentiate it, just differentiate it with respect to x to the power n formula, that is n x n minus 1. So what is n here? Half, that's why half. Now when you will do n minus 1, so half minus 1 you will get minus half, that's why it will move down, and because of half root will come. I am repeating from here to here, that is this 1 upon 2 root 1 minus x square came because of n x n minus 1. So n is half, that's why half. Now when you will do half minus 1, you will get minus half, and because of minus half, it came in the denominator as root. Now here you have to apply the chain rule in the bracket. So when you will apply the chain rule, 1 differentiation is 0 and x square differentiation is minus 2x. Now simplify, 2 will cancel by 2, this minus n becomes positive. So you will obtain this, and take it, because the denominator same in both the terms, so LCM is going to be the same. And after LCM and after all the simplification, you will obtain this. So this is your second order derivative. Now in the required result, we substitute the second order derivative, and when you will substitute here, this is 3 upon 2. So this 3 upon 2 you just write as 1 plus half. That's why here you will get here you will get like this. So substitute the second order derivative value here, and then minus x, and then first order derivative value here, and then this minus 2 as it is. Now here you can see this bracket and this bracket can get cancelled, and then separate this denominator. So when it will go with this, you will obtain only 2, and this term you will obtain like this, and these terms are as it is. So you can see that this 2 and this 2 will cancel each other, and these middle terms will cancel each other, so you will obtain 0. So the question number 8 also like this it is completed. So in this I taught you two questions, question number 7 and 8, and in that we have to find out the first order derivative first and then second order derivative. And while finding this, you have to take care of three formulas, that is the first chain rule, and then if you are getting them as a product of two functions, then u dot v formula, and if you are getting them as a fraction, then use fraction formula, that is denominator square in down in denominator, and then denominator as it is, then differentiation of numerator, then numerator as it is, and then differentiation of the denominator. So like this you will get the solutions. Thank you.